When you hear HTTP server in C++, you think some nerdy code getting too complicated. You know what? Not this time. In the next few minutes, you are going to see how to install Crow framework, set up a simple server in single file and grow it to the solid project structure with those get, post, put, delete methods of REST API. So without further ado, let's get started. Let's quickly install the Crow framework, go to get started, and you can see here Linux installation guide. You can install dep package, I recommend you to do that, or alternatively you can install archive or build it from source code from GitHub repository. macOS, you can brew install Crow, easy. Windows, VS packages install Crow, easy, or build it from source code. Yep. So let's start implementing simple server in single file. It can be useful for those who are not going to implement whole server, but just simple server with couple of endpoints to execute some useful scripts in C++. Yeah. We have included Crow library and we initialize simple app class instance, which comes with simple configuration for our server. And using Crow route macro, we initialize our endpoint, which takes app for first argument and path. And Crow route macro takes lambda function, which is a handler of our request. And for an argument, it takes a request. It's a whole request with body, and returns Crow response. For sake of example, let's just return hello world row string. In the next endpoint, we will see how to parse path parameters. Using Crow route macro, we initialize an endpoint, and the path parameter is specified with following syntax with angle brackets, and inside we specify the type of parameter. And in the lambda function, we should take this parameter. We just specify std string, and Crow library automatically detects it and pass the path parameter value to our handler. For the sake of example, let's just return raw data. Now, to run our server, we just specify the port and call the run function. Now, let's execute and see the result. In our first error, and this is because we are taking non-constant request in our handler's argument. It should be constant reference to our request. Let's correct it real quick and run it again. Here we go. Server is run on port 8080 using 2 threads, which is default. Now let's start implementing professionally structured REST API project, which is gonna be really interesting. Let's create project folder REST API and open it in our VS Code. Now let's start setting up our project structure. We create dedicated folder for header files, which call it include directory, and src directory for source files. And our first source file is main.cpp, which gonna have simple hello world just for now. Let's configure our C++ extension to successfully identify the external libraries we have installed. To do that, we just add the user include folder and user local include folders to include path, which helps to our extension to find all those libraries we have installed in our system. Now let's start configuring our building system, the CMake lists. And the first property is CMake minimum required. We specify the minimum version of CMake to build this project. And the project property to specify the project name, it's gonna be REST API. And then we should find the packages or libraries we are using in our project. So we will use find package property for that purpose, and we need just crow, and we just require it. Next, we should link all our source files while compilation. For that purpose, we use add executable property, and the first parameter going to be the output file name, and it's going to be project name. We just use constants, project name. Next, just list the path to our source files we have in our project. For now, we have main.cpp. Then we'll link the libraries we have using in our project. To do it, we use target link libraries property, and the first argument is the target, and the target is our project. We specify the project name, and then in the public scope we link our crow library. And the last thing we should do is link our header files which are located in include directory to successfully compile our project. And we use target include directories property, and the target is our project name. And in the public scope we list the directories should be included while compilation, and our directory is located in root folder. For that purpose we use project source dir content, which returns a root folder of our project, and in that folder we include our include directory. Now let's try to build our project using cmake. We go to the build folder and run cmake dot to specify that our cmake list.txt in our previous folder, and then run just make, which builds our project. As you can see, REST API output file, and as you can see, it's working absolutely fine. Now let's start actual implementation of our REST API, and we will start with our handler classes. In the include directory we create a subdirectory called handlers, which will contain handler specific code, and in handlers directory we create interface.hpp, which will define our interface class. First, let's include our crow library and define our iHandler class. And iHandler class, it's not a real class. We cannot create an instance of it. It's interface class that acts as a contract that all our real API handlers must follow, and all our real handler classes must implement register roads method. That's why we are creating pure virtual function register roads, which takes a crow simple app as an argument. And for the sake of convenience, let's create namealize, call it app, that will mean simple app from crow, and use this app in our register roads method. Now let's create base.hpp file where we implement our base handler. This class inherits from our interface class we have created before and provides common functionality that all our real handlers will need. Yes, it's an abstract class. We also cannot create instance of it, rather we inherit from this class our real handlers. So the common features all our handlers will have is our base path for routing purposes, and it will include standard error response methods. This means we write these helpers once and reuse them throughout our code base. Now let's create user.hpp file where we're gonna see a concrete example of our real handler, and it's gonna be our user handler, and this class going to be inherited from our base handler. And in the constructor, we are going to take necessary data to initialize our handler successfully, and which is our base pass. Actually, base handler should also take base pass. Yeah, let's correct it. And then we must implement register roads method, because our interface saying that the handler will be considered as a handler when it implements register roads method. Class handles all user-related operation. For that purpose, we should create handlers that list users, get individual user, create user, update, and delete. And notice that our functions has different kind of arguments. For example, list going to take whole request, because we are going to parse URL query parameters like page or limit, and getting individual user just take an ID, and creating, updating, they are taking request, because we are going to parse the JSON body content to create our user. For the sake of simplicity, we are going to hold our users in memory. For that purpose, let's include an unordered map data structure and mutex to prevent race conditions when multiple requests hit our API simultaneously. Now let's create map of our users, which gonna take as a key user ID, and as a value we are going to create custom data structure. For that purpose, let's create models subdirectory, and models subdirectory going to hold data models. And let's create user.hpp, where we're gonna initialize user struct with ID, email, and username. I think that's enough. And let's include our user model in our user handler and create last ID variable and the mutex. Now let's create server.hpp in our include directory, where we're gonna implement server class, and it's gonna be our main engine that brings everything together. So let's include our crowd.h and define our server class. And in the constructor, we are going to take server config structure that's gonna be used to customize important parameters. So let's define our server config struct and the parameters we are going to have is the port number and thread number to use for handling requests, log level, and enable cross settings or not for browser security, and the cross origin. Our server has three main operations, and the first one is start method. This method launches the HTTP server and begins accepting requests. And the setup function going to set up our all handlers. And we have add handlers method, which gonna take as an argument shared pointer to the iHandler interface, which means we can pass any class that implements iHandler interface. And then let's include our interface.hpp. Here we go. Now let's implement our member variables, and the first one is our server config, and the second one is the unique pointer to our crow application, and we are using namealize app we have created in interface.hpp, and we also maintain a vector of handlers. Now let's start our implementation of these classes. We are going to start from our server class. Let's create in src folder server.cpp file. Actually, I have realized that I forgot to include some libraries, for example, for our smart pointers, memory library, and to our vector that holds our handlers. Let's include the vector library. Now we can jump straight into the server.cpp file and start implementing our server class. First, we have a constructor. Here we initialize the server with a configuration object. We begin by setting up appropriate logging level based on the config. Whether the config, that's debug, info, warning, error, or critical. Next, we create our crow application. Using namealize we have created in interface.hpp. Then we configure our course, which is crucial for browser security. And app has a get middleware, and as a type name we pass the constant from crow library called crow course. Actually, it's time to change the simple app to the real app of our crow framework. Let's go to the interface.hpp and change the simple app to the app class, which gonna take a middleware in a type name, in here, and we should include our header, our library, appropriate library for course functionality, and it's a crow.h, middlewares, and course middleware. Here we go. Now we can go back to our constructor, and now we can get the course middleware and start configuring it. We define which HTTP methods are allowed, what handlers clients can send, and which origins can access our API, and that's it. And as a cache duration, actually we should configure our course if the configuration course is true. Now let's start implementing our setup function. And our setup function directly relates on add handler method. So let's implement our add handler method, and which takes a shared pointer of our iHandler interface. So let's copy real quick. Then let's implement it. First, we need to push back to our vector our new handler reference. Next, we should call the register routes method of our handler so that it registers all the routes and the handlers it has to our application. Now let's start implementing our start method, which kicks off everything. It calls setup to register all handlers. Then in the app we call the port function to specify the port from our configuration. Then call the multi-thread function that will tell that our server going to be run in multi-threaded mode. And the concurrency function, we are going to pass our thread number from our configuration. It will tell the server how many threads it should run. Then we call the run async, then it launches the Crow server. Now it's time to implement our handlers. So let's create a handler directory in our source folder. And in the handler directory, we are going to create a base.cpp source file where we are going to implement our base handler. So the base handler, which serves as a foundation for all our API endpoints and API handlers. And let's start with constructor, which is really straightforward. It accepts base, pass, string, and initializes the member variable. Then we have 3 utility methods that create error responses. Let's start with batch request. Our utility function is going to respond with JSON body content. For that purpose, we are going to use the feature of Crow to work with JSON. We just need to create an object of Crow JSON W value. It means we are creating writing JSON, write value. So we are going to write the values to this JSON. And we are going to work with this data structure as a map data structure. It's really similar to it. But the value can be any type. So let's write an error, the message, and Crow response, body request, and response. Let's copy and paste all this function and implement the other methods, not found and internal. Here we go. Now let's straight jump into our user handler. Let's create a user.cpp file in our handlers folder and start our implementation of our user handler class. Hey, are you sleeping? If you are still here, it does not matter if you are half asleep or wide awake, you are truly a hero. But let's be honest, you have probably dozed it off or turned it off this video by now. I'm pretty sure about that. Yet if you are somehow watching until this moment, I have to ask, why, bro? Why are you watching and how you are watching? Please leave a comment. Let me know about this. I will remember you as a real champion. Because, actually I made this video to help people fall asleep and have a sweet dreams. Just like those university days listening to monotonous Indian professor lectures, Oh gosh, I miss falling asleep so perfectly, peacefully back then. So, I designed this slightly technical tutorial to be a perfect sleep aid. But, if you are still here watching, I'm genuinely shocked. I don't know how. Please let me know. But yeah, let's back to our tutorial. We are going to finish our HTTP server. Really interesting HTTP server. So let's implement our user handler class. So let's start initializing our constructor. And it's going to be initialized with base pass that sets up the base pass in our base handler too. And we are going to set up some mock data. We are going to create 2 sample users to populate our in-memory database, giving us something to work with right away. Yep. Now, let's define all of the handlers we have, like this. Now let's define the register rows function too. Then start implementing the list method. And list method fetches all users. It supports query parameters. For searching, we are going to parse queue_param. And for limit and page, we are going to parse them and convert them using standard functions. S to I means string to integer, yeah. Then let's print it out, some configuration to ensure that we have parsed them successfully. Then we are going to construct JSON response. We already have seen how to do it. We are going to use w_value, and for the list we can use w_value list. And we are going to loop through users, create a user JSON, write user data. We are using second because the list is a vector of pair. Yeah. And push back to users. And we are going to use std_move to move instead of copy for efficiency. Next, our easiest method, getting the single user by ID. So we check if the user exists or not. If it does not exist, we are going to return a standardized not found error we have defined in base handler. Yep. It's inaccessible because in the base handler we have defined this as a private. We should define them as a protected so that the inherited class can use them. Yeah? Here we go. We have resolved the issue. Nice. If the user is found, we are going to build a JSON response with the user details. Let's copy it, and here we go. Now let's start implementing create method. In create method, we are going to use different type of JSON object. It is a crow JSON R value. R value means it for reading. We are creating the JSON for reading, and we are going to initialize this object with crow JSON load and pass to the load a request body. The load going to parse the JSON from request body and initialize our JSON object. Then we can extract the username, email from the request body. We can use dedicated functions for for type conversion. For example, S, it means it converts the value to the string. And we can use I for integer, B for boolean, and etc. You can learn it for yourself. Okay. Then we are going to store it into our database, and notice how we use a mutex log to prevent race conditions when multiple requests modify our data simultaneously. Like this. And we are going to return the user details. We can copy and paste it, and here we go. Okay, now to update method, let's copy the create method because they are pretty the same. And let's copy from get method searching. Yeah, we are searching for the user. If it's not exists, we are returning a not found. And if it exists, we are loading the request body, parsing the username and email. And instead of creating, we should update the existing one. Let's remove this one and let's fetch the user from our database, from our map by ID. Then let's update the username and the email from the values we are get from our request body. And then we are going to return the user details, and that's it. Now remove method. Let's copy the searching the user, and then in the log we are going to erase the user if we found it, like this. And let's return a message that it's deleted successfully. Now the most interesting moment. We start registering our roads. And for that purpose, we are going to use not crow road, but instead app dynamic road. Actually, road dynamic, like this. And it's gonna take an argument, a path. We are passing the base path to this. And we call the methods function and pass the available methods that this endpoint going to serve and call the handler for that endpoint and for that method. And as a crow road macro, we are going to pass a lambda function and pay attention to that we are passing this class to the context of our lambda function to have an access to the methods of our class. And as argument, we are going to take a request and call the list method and pass our request to it. Like this. And here is the interesting question, why we are not using crow road macro? And simply because the crow road requires us to pass a static path like this, API v1, we cannot pass this base path as a string, which is a string value, std string, If we pass it, we are going to have a conversion error. It says that I cannot convert it to my blackmagic const string. For that purpose, we are going to use app road dynamic. We just change it and pass the path, and other methods stays the same. Okay, now let's see how we pass the path parameters like this, and we are assigning the type of our parameter here. It can be string, but in our case it's integer. And let's assign methods. This is our get method to get individual user. Let's copy it and paste, and lambda function. In the lambda function, really interesting thing is that we are going to add initialize an argument, which is an integer ID, and the crow going to parse the parameter and pass to our function here automatically. And we can actually have multiple parameters, for example, load string and OPP, string. And to parse them, we just need to initialize an arguments in our lambda function. For example, string Juliet and string OPP, and it's going to parse them automatically and pass to our function. Trust me. But for now, we need just integer, and we call the get method of our class, this get handler, and pass the ID. That's it. Now let's copy the route initialization and configure all other handlers. Now, yeah. Okay, now we're ready. Our user handler fully ready to set up our server with our new handler. So in here, we are going to call addHandler method, and inside it, we are going to initialize using smart pointer, shared pointer, std make shared, and in the type parameter, we are going to pass our user handler. Actually, we should include it. Let's include user handler. But let's include it in server header file. It's going to be more correct way to do that. Like this. And now we can identify a user handler, and we are going to pass our pass parameter like this. Okay, now I'm pretty sure that everything is ready and our server can be run. So in our main.cpp, let's include std accept, because we are going to create a try catch scope here and catch all the errors throughout of our project here. And let's include server.hpp here, and let's start initializing the server config struct. The server config struct, we are going to set a port 8000, 4 threads, logging level is debug, course, we are allowing the course, and allowing origin is all. Yeah. Now let's initialize our server using smart pointers std make unique, and as a type parameter we are going to pass our server, and we are going to pass argument config here. And let's call the start method of our server. After, we are going to return 0, and we return -1 if here is some error. Yeah. Finally, now let's run our server. So cmake, make, and boom. Okay, we have an error. Okay, this is because in the cmake list we are not specifying all source files we have in our src folder. So let's add them, all of them, and let's run it again and see the result. Now let's make building it, building. Okay, come on. Bam. Okay, here's no error in compilation. So here's our executable, we run it, bam, our server is run on 8000 port. As you can see from the configurations, we have a debug level, logging, and 4 threads. Here we go, everything is working fine. But now is a time for testing, to be sure that our API, our endpoints are working correctly. Okay, now we are in Postman. Our server is running, and let's get all the users. Here we go. Here is our mock users. All are there. And let's get individual second user. Yep, by ID. Here we go. Everything is correct. Okay, now let's create new user actually. And we are going to copy and paste from the individual user, change a little bit to ASA, and email also ASA, and method name is post. Yeah, pass is users, and here we go. Okay, here's the details. Details are correct. Let's get the users to see, to verify that we have the user inserted. Yeah, here we go. And now let's update the third user we have added. And we are going to add second name, Do, and here too, an email. And let's update it. Yep. Okay, details are correct. Let's see it. In the list. Come on. Okay, working correctly. Let's delete this user we have just created and updated. Okay, working. And let's actually get the third user to see that error handling working. Here we go. Okay. Yes, everything is working completely fine. Yeah, if you are somehow remained engaged until now, please drop a comment below. Or if you are already sleeping, okay, good night. Either way, thanks for sticking with me through this deep dive into C++ server architecture. Your commitment will not be forgotten. Thank you for watching. Peace.